Welcome to the Ex Terra Podcast. The Ex Terra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Ex Terra website, as well as on this podcast. And my guest is Barbara Belvisi, founder and CEO of Interstellar Labs, which is developing environment-controlled modules equipped with an automated aeroponics system, which is kind of a mouthful. Barbara, thank you, and welcome to the program.
Thank you. Thank you, Tom, for having me.
Let's talk a little bit more in depth, first of all, just about what it is that your company does.
Sure. So the purpose of Interstellar Lab is to recreate the structure where we will create the perfect condition for life to grow. And our purpose is to protect life on Earth, but also to help bringing life to other planets. And we start with plants and the biodiversity that we have here.
So give me a little bit about your background, if you would.
Sure. I'm not an engineer, didn't study aerospace or biology, but very passionate about those topics. Though I was super nerdy as a child and I always dreamed of becoming multiplanetary. I drew, flowers in my room because I was dreaming of living under a dome full of flowers and plants. But that's it. I did a pretty successful career in finance. I started multiple investment funds, help over 400 companies all over the world building hardware and robotic products. And after a certain point, I realized that I will not find this entrepreneur who wants to build the systems I was looking for, the structure to protect life. So I just decided I will do it myself. So I surrounded with engineers from NASA, SpaceX, and here we are right now.
Let's start off then on planet Earth. How did you conceive of this biopod concept?
So we started with a vision of a station for 4 astronauts on Mars. And so we designed, it was more than a concept, it was like preliminary design intention of what could be a modular base on the surface of Mars. And so we sized a different system and we came up with a pod that will be fully inflatable, where we will control all the climatic conditions inside. And then we made an iteration to actually build the first prototype as a terrestrial product. So we had to, our constraints were terrestrial in terms of the manufacturing of the first pod. And so we came up with this design of something that is in the form of an ellipse because it's much better for the airflow and the circulation of the air inside. Also, it's an inflatable structure, so it cannot be rectangular. We wanted no structure actually completely inflated. And we choose not to make a sphere because problem with sphere is that you're losing a lot of space on the edge, and we wanted to work towards space optimization for plant growth. And it's actually also a mathematical equation that we used to design the whole pod.
So then what are some of the terrestrial applications for the biopod?
Biopod is used, so right now we have over 70 commands, pre-orders for the pods. 3 types of customer. One very big group is on pharmaceutics and cosmetics. So what we're bringing is we really localizing the production of specific plants they need, to produce. Sometimes it's a shampoo, it's a cosmetic product, but also it can be a drug to treat, for instance, cancer or some other diseases. And so by recreating the specific climate, instead of sourcing the plant in Indonesia or Madagascar, they can just grow it next to their facility, and we really optimize the conditions so the plants will produce more molecules that they need. That's the first group. The second group is really food production. So we're providing a solution for food deserts. On this end, we're actually working very closely with Texas and a couple of different areas in Texas that are registered as food deserts, but we also work with the Middle East and especially Saudi Arabia. The third application is like research and biodiversity conservation. So we have a lot of very big universities getting the pod to recreate the climate to grow endangered species and to study how we can grow in a controlled environment different plants.
Let's talk about the development process just a little bit. How did you go about testing your prototype, and what did you learn from that process?
Sure. So what's complicated with inflatable structure is that it's not like you can build a smaller version of the biopod and then test all the system because because it's going to be different from a small size to another size. And so testing on a small side can allow you to understand certain thing, but it's not a proof of concept for the full size biopod. So the way we approached the prototyping was actually more on the testing of the system themselves. So how we can automate them, because there is a lot of automation on the biopod. So combining the sensors, our intelligence, and how we will activate or not activate the hardware. So that's how we worked on the prototype. And then also we developed smaller version just to see how we can be able to control the microclimates and how we will manage to grow plants. So we have over 4 feeder trons, so huge tents where we recreate condition, and we've been growing plants. So we did vanilla, marigold. We did a lot of plants. We're growing fruits right now. We have gooseberries. It's passion fruit. It's really cool.
So did you take it to a harsh environment for the testing, or were you in the tropics somewhere where it would be easy to grow things anyway?
No, it's tested indoor. So everything is indoor in our facility. So we have a big facility at the south of Paris. Very, very soon we're bringing everything in California, early November, and you'll be able to test our system in Cap Canaveral, hopefully by the end of this year, if not early next year. So we've been testing everything indoor, and so really like recreating the climate and see how we can grow them. So we're so it's not a hard environment, but it's like really the purpose was really to see how we can recreate inside the structure, the climates. The second part of the testing, which will be to test outdoor, the pod is going to start this summer. Right now we are assembling the first full-scale biopods, and we're going to keep 2 in Paris and bring 3 United States for testing purposes.
And then that'll be done in a desert environment, or just kind of give me a sense, if you would, as to how you want to do that testing.
Sure. So in Paris, we're going to keep one indoor because we're going to change some of the hardware system, and we'll iterate on the automation and the intelligence of the pod. The second biopod next to Paris will be outdoors. So it's a temperate climate, but we will measure the difference between a pod being inside and outside, and how we can optimize power consumption based on the light we're getting from the sun. And then the 3 we're bringing to United States, one will go to Florida, the second one will go in Texas, and the third one in California. So they're pretty warm climates. That said, we're in discussion with Alaska also to bring one over there, but we do it like step by step. Testing in different environment and then pushing it to the edge to see how the pod is reacting.
Well, I'll tell you, I'm in Florida, and it can be a pretty harsh environment here as well, but always on the hot side, so never cold.
No, never cold. But you have hurricanes and winds, and that's a very good way for us to test how we're going to approach dust storm on Mars.
We do have those now. You've talked about current farming practices that overproduce and produce low quality food. So how can biopods help the terrestrial farmer?
Sure. One of the main issue is the consumption. First is the consumption of water. And so by recreating a completely sealed system where we capture back the water that is in form of vapor inside the biopod, we actually use much less water than traditional farming. And so we capture it back, we put it to our water treatment system, and then it goes through again the aeroponics. So it's like it's a regenerative circle, and where, of course, there is some water that is going into the plant, so the plant can produce fruits or vegetables and flowers. But so it's a very low consumption water system, and that's one of the biggest problems with food production currently. Current food production also, we are a lot of people on this planet, and I will be in favor of like cultivating all around and just having soil and a sustainable agriculture. But the reality is that because we are so many, having a traditional agriculture system doesn't work, and it's hurting our soil, and we cannot produce enough food for everyone. So indoor farm is needed. And the good thing about indoor farm and aeroponics is the fact that you're not hurting the soil, because you're cultivating everything, out of soil and in a system. So it's preventing from pollution and from soil deterioration. Another thing is also, the more land you give to agriculture, the less there is for wilderness and biodiversity. And I think, because again, it's a question of number of people and allocation of resources on this planet. we need to give more land to wilderness so we can protect the biodiversity that we have on Earth. So indoor farm is really a solution. A solution that can help do that. The main problems with indoor farm is the power consumption. So it's how to optimize the power consumption. And that's why we've been innovative in the material we're using for the membrane and the optimization of the automated system. So you don't use too much power for the LED, for instance.
So give me an idea of how big one of these is.
Sure. Oh, okay. I'm talking square meters, so I'll try.
Okay.
But that's the first size. So the first size of the biopod is 55 square meters. So it's roughly 600 square feet on the floor. And it's 6 meters high. So it's 2 times as high as a container. And 6 meter wide. So it's actually also, so it's like you will stack 4 containers. Together, you'll get the size of the biopod. So it's pretty big. I think the renders we have don't give this like a sense of order of magnitude of the system we're building. But that's the first size. That's also one of the reasons why we choose inflatable. It's a good entry size. It's like 600 square meter on the ground of like growing area. So it's actually, we came up with this figure because this is how much you need in terms of surface to generate enough oxygen and food to sustain life of 1 astronaut, like if you don't take anything else on another planet. So that's how we came up with the size, to be fair. But you can the second size of the biopod is the size of a tennis court, and it's the same technology. It's inflatable structure with an airlock at the entrance. So we're going to grow in terms of sizing for scaling.
I'm talking with Barbara Belvisi, founder and CEO of Interstellar Labs on the Ex Terra Podcast. Take a minute right now and click on subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. All right, Barbara, now let's go to space, which is a decidedly harsher environment than it is here on Earth, even for Florida. How do you envision the biopods being used? And you've touched on this a little bit already, but let's go a little bit more in depth on how you see them being utilized in space.
Sure. So for our space, the first market right now will be in orbital station. So it's going to be a different form factor than the biopod. So what we've been working on is actually small cubic system where we recreate perfect conditions so we can grow plants, something in between the current system that are in the ISS, which are called VGs and APH. And so we are developing one that is a bit more advanced than VG, but less complicated to run than APH. And so the first step for us will be to send the system into LEO and to get the data on how plants are growing. One of the main struggles NASA is going through when it comes to plant growth in LEO is the watering system. So we're actually working with several teams at NASA to develop a better solution so we don't kill the plants out there. So that's the first application of the biopod, is really for research and studying plant growth in microgravity environments. And of course, the second step in LEO will be to develop a module, a full module equipped with a plant cultivation units. Towards this end, we have several agreements we're working on with the orbital station, and I think we'll be able, sometimes I'm a bit too optimistic on deadlines, though I was not that late for biopod. We were supposed to install the first one 2021 and it's 2022. So including COVID, it's okay, I think.
So there was this little pandemic thing that happened. Yes, exactly. It's hardly worth mentioning.
It's okay, it's not that bad. And on the orbital station, we probably will be able to send one of our smaller system before the end of this year. It's super short, but we'll do our best. Other one is going to be next year, and a full module probably by 2024. So it's very exciting. Then on the moon, it's a different deal. So what we're planning on doing is also super small payload to see how our watering system is reacting to lunar gravity and lunar environment, which is very different than LEO environment. And at the same time work on the deployability of our system. So we'll see if we need robots or if we can do a system that is fully deployable by itself. The goal for the moon, the first step will be really to contribute to the sustainable moon base. So as part of the Artemis program, so to put one of the first greenhouse on the surface of the moon, and then to get data and to prepare for a Martian product. The big vision behind all this company company was, if we can put some green out there, maybe we can elevate our human consciousness on Earth about, why we need to preserve our biodiversity here.
So without giving away trade secrets, how do you water plants in microgravity?
Sure. What we're looking at right now, because it's a super, for the first pilots that are pretty small, it's a passive system. So we're using the capillarity, and we isolate a part of the root. So one part of the root can access oxygen and the other part can access water. Because the main problem with the root is that if you put a drop of water on a root system, it will just like encapsulate everything, and then it will kill the plant. And so we're testing different mediums. So it's all about the substrate and the medium you're using to contain the water, so the root can access the water. So that's what we do for passive system. For non-passive system, we're still exploring an opportunity to use a different type of aeroponics. We'll see. We need to run a lot of experiments, to be fair.
Now, Barbara, your nucleus system won phase 1 of NASA's Deep Space Food Challenge. So talk to us about the challenges, about that particular challenge and the nucleus system in general.
Sure. So the goal was, so the constraint of this competition was, we were giving a constraint in terms of size, of mass, of resources we can use. And the idea was really to optimize the input and the output. So taking as less input as possible and optimizing the output and generating, less waste as possible. And so we came up with a combination of structure of units. Each unit is very similar. It's like a biopod, but just a different form factor in a cubic version. But it's a controlled environment where we control the atmospheric, all the hydraulic system, and where we recreate the conditions for the plants so they can grow. And so what we did is, so it's a setup of nine cubes, inside which we control specifically the condition, and they're designed to grow microgreens, mushrooms, and insects. And so we use, O2 that is generated by the plant to feed the mushroom. We need inedible parts of the plant and the mushroom to feed the insects. And so we recreate this balance among the 9 different units. Now we're working on the prototype, so it will be installed at the end of the summer at the Kennedy Space Center for testing purposes. We're gonna start with the microgreens and the mushrooms. Then we'll see how we can incorporate the insects in the system. That will be a challenge because we've been dealing with plants only from the beginning.
That is interesting because people, I guess, often don't think about the fact that the insects are necessary for the sustainment of that kind of an ecosystem. You can't just have the sterile environment and grow plants. They just won't grow.
Yes, exactly. And in fact, we're using insects on Earth for pollination inside the pod. So it really depends on what you want to grow. But if you want to grow fruits, you need pollinators, and bumblebees are the best. So there will be a certain part very soon on Earth, pods just dedicated to also preserve bees, and I'm very excited on this one.
You'll have little teeny tiny drones that'll act as the honeybees that'll go around between the plants.
Yes.
And that's really not that far out of the realm of possibility, I think. But
no, it's not. Yeah.
Anyway, you also received a pre-seed round of funding at $5 million. Can you talk about the investors that were involved and what those funds are going to be used for?
Sure. So the first round we did before this 5 million round was dedicated to onboard more business angels. So we had super cool angels, some who are involved in Planet Labs and SpaceX, and so very good advice from those people who joined super early on. Some other were involved as well in robotics and AI. And with this round, we actually onboarded more venture capitalists. So it's a combination of VC specialized in space, like Earth Tomorrow Capital. We also have Seldor Capital. We have Urania. We have Isart. So really good guys. And also combination with them and more climate VCs. And agri-tech VC. So the idea was really for us to be able to have around the table people who understand the space business, but also people who understand the terrestrial application. So we are not going to be pushed too much into one direction in the future. And we have great. We also onboarded a capital factory in Texas. They're based in Texas. It's really good for us because it's helping us access the Texas market, providing terrestrial solution for food, and also working with all the space player over there in Houston.
Now, you're currently in Los Angeles. You've just participated in the Space Tourism Conference. Can you talk, kind of give us a synopsis for those who weren't able to attend, what you talked about as far as how this all fits into space tourism?
Sure. It was really good gathering, and it was awesome. We had like Dr. Kupma for Axiom, who was there as well, and so the main purpose of the conference was really to gather all the players that are helping advancing commercial flight and space tourism. On our end, I talked a lot about the how we can prepare for astronaut training, and because I expect it's going to be in 5 years from now, it's going to be very part of our daily life to have people just like going to a space station or doing spacewalk. It's going to become super. I hope. and so on our end, I was talking a lot about how we can develop on Earth analog system to actually help on the training for future mission on the moon and also future mission on Mars. And I think right now the analogs that we have there, it's really cool. But I think we need to move a step forward and adding more and more technology so we recreate the condition that are closest to what it will be to live on the moon.
So you're talking more about doing that as a training aspect as opposed to being able to provide food for potential tourists either on a private space station or at a moon resort, if you will, or things of that nature. It's more about the training for you?
I think we'll do both because for us,
whatever they ask.
The thing is that our technology has like so many applications, and it can be used for for pure tourist purposes and education. And for me, it's very important that we educate the people and that we use real technology to explain how we're going to grow food and how we're growing food. So I can see our technology be used on pure tourist application with this vision of like bringing science and making science accessible to anyone. But also it's the same technology can be used for super advanced analog and astronaut training. So even though there are two different markets, for us, it's the same use of our technology.
Are they modular? Can you take them and put a bunch together and make one big, huge farm?
Yes, you can. Yes, you can. So this is how we design everything. When we started, the first thing that I announced in 2019 was actually this modular station where we will combine different pods to recreate a living environment.
What else is on the drawing board for your company? I mean, do you have that at least you're willing to talk about?
Sure. Yeah, there are some, confidential projects, super cool project we're working on, and fingers crossed we'll be able to join this mission before the end of this year. So right now so the team is 26, 27. Most of the team has been flying in France for the first assembly, but all the team will be back in the US in September to assemble the pods here. So we need to double the team. So I'm recruiting a lot of engineers. So if you're an engineer, you're looking for a position, feel free just to send an email or reach out. So that's one part. The big thing for us by the end of this year, of course, will be to demonstrate the biopod and to install them and start the testing. But this also will be to decide where we're going to put the production line. So as we have over 70 demands of pods without even opening pre-orders, just word of mouth, we want to reach a path of like 100 pods produced a year. So it means we need our own assembly line. So that's something big for us. It's going to be done whether in Texas or in Florida. Yeah, a lot going on.
I'm a big fan of Florida. Come on, we'd love to have you. We are just about out of time, Barbara, but if you could just take a quick look out into your crystal ball over the next 10 or 15 years or so and think about space commerce and the role of your company in it, and tell us what you see.
I think the access to LEO will have many civilians going there. Price going to decrease, and I think that this vision that many company had, I think most of the people actually in the space industry, whether it's SpaceX, Virgin, or Blue, it's all about also bringing the overview effect to people, so we can, open more about this consciousness of our planet. So I see this really, becoming a thing, and the price going to decrease, and we're going to get a lot of people out there. But also, I think because of all the research that will be run in microgravity, we will learn a lot about the planet, but we also figured out many things that will have tremendous application on Earth. And I can see that happening, and I can see, finally people understanding why space exploration is so important for the crisis that we're experiencing right now on Earth. In 10, 15 years, 100% will be back on the moon, like 100% sure. That's what my crystal ball is telling me.
I'm writing this down.
So I will always say that, but we'll definitely be back on the moon. I think that sustainable moon base will start. There's going to be a lot of experiment. Hopefully, we'll have the first astronaut. I don't know if 10 years from now, 15, we're going to have the first civilians. I think, and I believe, I'm a huge fan of the SpaceX mission, and I really believe they can make it within the 10, 15 coming years to have a Starship doing a first mission to Mars. So we'll definitely see that happen. I mean, that's my hope for the future.
As long as Elon doesn't spend all his money on social media. Which is not terribly likely, but you never know.
No comments on my side.
And I guess as long as people are eating, there's going to be a need for your product. There's going to be a need to be able to grow food, so we don't just get all bored in space eating stuff out of a tube. It's nice to have a fresh vegetable.
It is, and it's needed. Actually, the reality is that we don't know how to create certain nutrients that are needed for human survival if it's not coming from plants. So you can have, pre-prepared food, packaged food, but the truth is that's why NASA is studying it. We need to grow plants because we don't know how to produce, specific vitamins.
Great. Well, Barbara, thank you so much for your time. It's been an interesting interview, and I really appreciate it. And thank you so much.
Thank you, Tom. Thank you so much.
Barbara Belvisi is founder and CEO of Interstellar Labs. And that is going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click subscribe so that you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.